Okay, now we've been wanting to call this axis vertical axis the y-axis, and we've been wanting to call this vertical axis the y-axis. And there's some confusion because the points on this axis here actually represent x values from this graph. So let's kind of remember where this all came from, but let's ignore the x and the y from this graph. And now let's call this a y-axis, and let's call this a y-axis. And if we call this the y-axis, then our graph is of the sine function. It's a sine curve. I'm going to define the sine function in terms of this graph, in terms of this model. So y is going to equal, in this case, a times the sine of t. Okay, so if the labeling has a here and negative a here, whatever those numbers are, negative 10 and 10, negative 0.002, 0.002, whatever they might be, then that number is going to go here, and we have the function of y equals 10 sine of t, y equals 0.002 sine of t, whatever. If a happens to be 1, of course, then this just becomes y equals sine of t. So here's the definition of the sine of t function, and here is the a sine of t function. Okay, and same down here. We get the cosine of t function. The function between negative a and a is a cosine of t. If a is 1, then the function becomes just plain old y equals cosine of t. Okay, we'll go on with that a little bit, but let's do one more thing. We are defining angles in terms of cycles, in terms of rotations, if you prefer, in terms of an arc distance on a circle of radius 1, but ultimately our default measure of angle is the radian, which has been defined here. Doesn't prevent you from thinking in degrees. You just don't want to do your mathematics. You don't want to do sine functions with your angles in degrees. Now you can do triangle trigonometry fine using angles in degrees because you're not doing derivatives and integrating the functions and so forth. When you start doing calculus with the functions and do certain other things in mathematics, you really want to be in radians. So, but it doesn't hurt to have the correlation. We've got 2 pi radians corresponds to 360 degrees. And then it's really easy to divide 360 by 4 or by 2 or take 3/4 of it and determine that we have 90 degrees here, 180 degrees here, 270 degrees here. And we could label them up here also. And there are correlations between the degrees and the angles that we're not going to talk about here. I think everybody should be pretty aware of those correlations between degrees and radians, and I'm not going to take time to do that. I want to get the idea across here rather than all the gory details that you've already been through.